Hi there brewers, my name is Eli and I'm the owner and brewer at Ill Intentions Fermentory and Distillery, located in Cherry Gardens, South Australia. We are a nanoscale, environmentally conscious brewery with circular economy at the forefront of our decision making. We run the brewery entirely on rainwater and have invested in enough solar generation to offset all our consumption. All liquid and solid waste is fed to our chickens, composted or used to irrigate the garden. We even heat the family pool with waste heat from the brewery. In this video, I will give a rundown of how I have set up a 300 litre Brewzilla brewhouse from Kegland, and will include my thoughts on the quality, versatility and ease of use as we go along. This system has been purchased in conjunction with 3 unitank fermenters and a glycol chiller, also from Kegland. I'll make more detailed videos on these items, but they are shown here to help visualise the entire setup. Purchase of this equipment is the second phase in Ill Intentions' business plan, which began with a trial phase using a brew-in-a-basket system capable of producing 50 litre batches. Having spent several years upgrading that equipment with Kegland products to enable pressure fermentation and closed transfer to keg, I'd become familiar with their products and have been impressed with their level of innovation. As we looked to scale up the brewery, we had a very limited budget to work with, but didn't want to compromise on quality, versatility and ease of use. Kegland's 3-vessel breweries stood out from other similar sized offerings, which coming from brew in a basket I could tell would be very hard work on brew day, in both running and cleaning. Initially I was considering the 200 litre Brewzilla, but soon changed to the 300 litre system, as among other things it offered greater relative maximum capacity in the kettle, ensuring I can comfortably produce enough wort to keg 300 litres. Also, the 300 and 400 litre models come with a sealing lid and hatch that allows the kettle to double as a still boiler. Key from Kegland was instrumental in helping me come to this decision, as he demonstrated that they had spent a lot of time researching, designing and testing their systems and really believed in their product. After locking down the items I wanted, the manufacturing process and delivery took around 20 weeks, including some shipping delays. In this time, I was preparing a 40-foot shipping container to house the brewery, which later will be extended to include a small tap room. The size of the 300 litre brew house is really too big to comfortably operate from a standard shipping container, and Key was very upfront about this. But I already had plans to cut mine wide open so that I could enjoy the view and feel like I was working outside. Having turned a 4-metre section of wall into a sliding door, the space now works nicely with the brew house and the rest of the kit. On delivery day, we had considerable logistical troubles manoeuvring the brew house into position because it came fully assembled and had a shipping weight of around 1100 kilograms. I had no real plan at the start of the day, but with a few friends and a couple of tractors, we did manage to get it into position. I really wouldn't recommend this to anyone else, but instead plan to have the right machinery on site and an easy location to install the brew house, because the thing is an absolute beast. Once in position, levelling was straightforward, working on the assumption the frame was welded square. I did find that a few tri-clamps had fallen off during transit, but everything was still in the box so it could be reassembled. All of the tri-clamps had to be tightened, so this was a good time to become familiar with the pipe tree and all the fittings. To power this system, I have a 40 amp 3-phase feed, which could be considered underpowered. However, this was carefully calculated to reduce costs, and I knew because each element can be individually switched, I would be able to manage power consumption on brew days. I haven't blown the breaker yet, with 2 of the 12 kilowatt elements, the recirc pump and the 6 kilowatt rims element all going at once. If I wanted to heat water in the hot liquor tank while maintaining a boil in the kettle, I can do this by using just one element in each vessel. Once up to a rolling boil in the kettle, 2 elements is too powerful anyway. Water connection to the hot liquor tank is straightforward. I'm running the whole brewery on filtered rainwater, so I've installed a 1.5 inch triclover fitting to my filter outlet, made a custom 1 inch diameter hose to bridge the filter and the brew house. On this system, all water flows through the plate chiller up into the hot liquor tank. This can be utilised to heat water for the next batch while chilling the boiled wort, or this hot water can be used for cleaning. I have another setup which I will discuss later. As I was setting up the brew house, I was constantly surprised at the quality and robustness of each of the components. Each tank is double walled with a polyurethane lining for insulation, and the tanks feel absolutely bulletproof. The false bottom in the mash tuns perhaps surprised me the most, with all 3 sections made of thick steel and are well reinforced. The sealing lid on the kettle is also super heavy duty, but the hatch lid is the thinnest feeling component. The hatch works well, but is very loud as it clangs open. A thicker lid with viewing port would be great, but it's a good place to save on materials for keeping the cost down. Everything about the system feels like it is built to last and very much looks like a miniaturized professional brew house. Upon arrival, there were 2 components damaged during transit. One was the kettle hatch, which was dented in and therefore wouldn't seal tight with the latching mechanism. The other was a crack in the sight glass on the mash tun. I informed Kegland of this and they immediately organised replacements for both items. Once all connected up, I began a simulation run with a cleaning solution to figure out how to operate the thing. Fortunately, even with no 3-vessel brewing experience, it is very intuitive and easy to figure out how to control each step of the process. The electronics used in the brew house are of excellent quality, with good reputable brand components used and well thought out control configurations. The pump from the hot liquor tank is either on or off and moves a lot of water very fast. To control this, you need to ease on the butterfly valve to get the flow you want, for instance during supply sparging. The water pump is controlled through a Danfoss VDF driver, so it's full control over the pump speed. I haven't explored any advanced features of this controller, but simply use the dial to increase or decrease the speed as required. The dial is quite sensitive, so only small adjustments are required. This all works really well, with the only downside to this pump being the high-pitched whining sound that it makes, which is most noticeable at low speeds. The kettle has 2 ports, with one being a normal fill port and the other being an angled whirlpool port. A cool new feature Kegland added after I placed the order was to have a racking arm in the kettle for transfer to the fermenter. This is an upgrade from a bottom drain port with hop dam, as it allows more control over preventing trub and hops getting caught in the filter before the plate chiller. I need time to optimise how I use this, as my transfers have been very slow due to the fine mesh filter quickly getting blocked, but I will keep exploring ways to avoid this. The kettle still has a central drain port for recirculation and cleaning. Each of the 5 heating elements can be set to manual on, which will keep the element on until you switch it off, or auto, which is controlled through the associated PID and thermocouple embedded in the tank. All 3 tanks have PID control, with the mash tun requiring the rims element option to have temp control. The pipe tree for the rims allows water to be circulated without running over the element until it runs clear, and then you can divert it over the element. There is a wire strainer before the rims element so it doesn't get blocked with malt, which is why it is important to clear your wort before sending it over the rims. No matter your background, anyone will be able to work out how to use this brew house, but I do want to provide a few tips for running a brew day so you don't have to learn the hard way. Start your day by filling up your hot liquor tank and getting it heating, then make any salt and mineral adjustments required. I set the hot liquor tank temp to 75 degrees Celsius with the aim to finish mashing in around 68 degrees. A trick I found with the hot liquor tank is that it will come up to temperature quickly, but the water at the bottom will still be cold. To fix this, you need to get in and give it a stir a few times to make sure the temp is uniform. If you don't do this, you will end up below mash temp once you move your water into your mash tun. Coming from brewing a bag, then brewing a basket, I always crush my grains very fine. I made that mistake once with this kit and would never do it again. Make sure you set your mill to a reasonably coarse crush to avoid a stuck sparge. Once up to temp and you have your grains crushed appropriately, transfer your water into your mash tun and start adding your grains. I remove the sparge arm as I mash in to stop it getting covered in dust and to give me a bit more working room for the mash puddle. If you need to adjust the temp up with the rims, then circulate the wort until you don't see many particles moving through the sight glass, then divert the wort over the rims element. Make sure you have sufficient flow over the rims element, because even set on auto, the rims will overheat without sufficient flow. This is because the temp of the mash tun is measured in the vessel and not at the rims element. Always have flow before turning on the element, then switch the element off several minutes before the flow to let it cool down. This applies to all the elements. Make sure they are submersed before turning them on, and then don't immediately drain the liquid from around them after turning them off. Once your mash is complete, you can either go straight to sparging or raise the temp to mash out using the rims. This will take a while if your mash is down around 65 degrees, so it would be worth starting that early before the end of the mash. Fly sparging works very well on this kit, as you can stand and fine tune the hot water in with the butterfly valve to balance with the wort out controlled by the wort pump. The only addition that I would find very useful would be another sight glass just before the kettle to be able to monitor the wort entering the kettle. Once the elements in the kettle are covered, you can turn them on and start getting up to a boil. As mentioned earlier, once at a boil, one element is enough to keep a rolling boil. I even had it blow out the chimney with just one element on a 200 litre batch, so this will need a bit of monitoring and maybe some manual switching. To knock down to whirlpool temp, that's 75 degrees for me, I connect a hose that will go to the fermenter after the plate chiller and direct it back into the kettle through the hatch. Extreme caution needs to be taken because this is boiling liquid. Before ending the boil, I use this setup to circulate boiling wort through the lines and the plate chiller to first sanitize them. When doing this, ensure your butterfly valve is open leading to the hot liquor tank because the plate chiller gets hot and will blow the hoses off if the cooling water supply is trapped and pressurizes. Once you have sanitized and are cooling down to whirlpool temp, simply run the plate chiller until your kettle reaches the temp you want. Then divert flow through the whirlpool inlet to get the wort spinning. Add your hops and give it the time you want before sending wort through the chiller again from the kettle racking arm and into your fermenter. There is an inline thermometer to measure temp into the fermenter, so you need to balance the transfer speed with your cooling power to ensure it isn't moving across too hot. This brewhouse comes with a 2-stage plate chiller. This means the water line that leads into the hot liquor tank is the first cooling stage, and then you can hook up a glycol chiller to bring the temp down even further. The glycol chiller I purchased is more than powerful enough to allow that, but instead I've connected my pool pump to this stage and heat my pool while chilling the wort. So I don't tend to use the first stage of the chiller for cooling while my pool temp is quite low, but might require more cooling once the pool has heated up. I'm not sure how many breweries out there are heating swimming pools, but I imagine this is quite unique. Once you have finished your transfer, the whole brewhouse needs a clean. I'll have shoveled out the mash tun during the boil, but then you need to drop out the trub and hops and rinse the vessels out. As we are sending all of the waste into the garden, I opt for a manual clean using a pressure washer and scrubbing cloths, but will occasionally run Kegland Stellar Clean through a CIP cycle. Each vessel has its own CIP setup, with this being permanent in the mash tun and a replacement for the chimneys on the hot liquor tank and kettle. With the right hose configuration, you can run the brew house as its own CIP cart and even get your fermenters as well. The only downside to doing this is that you need at least 125 litres of cleaning solution to cover the elements and the thermocouple. You could use less if using cold solution. I have been storing my cleaning solution in kegs and reusing it a few times. I've also been sanitizing my fermenters using boiling water in the same CIP configuration. Cleaning is always the biggest job of the day, and this system does not make it light work or trivial, but it is easy to see that other systems without conical vessels and central drain ports would be a lot more work. I find the pressure washer is your best friend, especially for the mash tun false bottom and the large strainer before the plate chiller. At this early stage, I'm getting mash efficiencies of around 70%, but I'll be working on getting those up a bit. I believe you could fit up to 125 kilograms of grain into the mash tun, but your mash will be very thick. My biggest grain bill so far has been 100 kilograms, and it was tight, but there was a little bit more room. I'm looking forward to pushing the limits of this machine in the future and exploring its versatility at both the low and high end of ABV. In summary, I think this is a great product and would recommend it to anyone looking to brew in the 200 to 300 litre range. Kegland also have available all the extra components you would need, such as hoses and fittings, to plumb it in or build a whole brewery. Thank you for watching this video, and check out my other two covering the Unitank fermenters and glycol chiller.